Well, now it gets even more serious. We're going to talk about what the spike protein itself actually is. And there's two mechanisms here that I want to speak about. Firstly, as a superantigen. So it's been observed, and you can see here on the right-hand side, that the spike protein resembles a toxin that's produced by a bacteria that's associated with food poisoning. So you may have heard of Staphylococcal aureus, which is the bacteria that produces Staphylococcal enterotoxin B, or for short, SEB, SEB. And you can see the structural differences, both in terms of the sequence and also how it's structured as well. Now, what do superantigens do? Well, an antigen, which is just like has epitopes, it can be recognized basically by the immune system, by the adaptive immune system, is normally recognized by specific shapes on it, right? Epitopes, and it stimulates perhaps T cells that recognize those specific shapes. The problem with a superantigen is it has this broad, massive reaction with T cells. So they get overstimulated, the mature T cells, not in a way that's particularly dependent to one or two little shapes on it, but broadly, it leads to a proliferation of these T cells that can cause inflammation and damage to the body. Also, superantigens can even reduce CD4 and CD8. Those are T helper cells and your cytotoxic T cells. So it can cause problems to your T cells. And if you know about, for example, HIV, you know that's really how we can determine if somebody's infected. It's to do with the ratio of the CD4 to the CD8. It can also cause autoimmunity, those T cells, and induce neurological complications. And we're going to see this theme a lot, neurological complications.